All right, we are going to start the review for the Unit 7. I'm just doing a video review for the first learning objective. So the other two objectives, the graphing and the solving, you'll just have to go to regular Blackboard 9, Unit 7, and look under the reviews. All right, what you'll probably want to have in front of you is your exponent table, and I am going to take out all of the coefficients if they're not perfect by looking for factors that are perfect. There are a couple problems that I will do a part 2 to the video review in case you want to get the coefficients out the same way you take the variables and the exponents out, but that'll be a second part, and then that won't be up until Tuesday. So starting with number 1, looking at the fifth root, the first thing I want to check is does anything in there have a perfect fifth root? And everything does. So I'm just going to take the fifth root of everything that's in there. So the fifth root of 243 is 3, the fifth root of x to the fifth is x, and the fifth root of y to the 15th is y to the third. And again, the idea is I'm dividing the exponents into the other exponents. And what I get as my quotient when I do that division is the new exponent number. All right, number 2, what I'm going to do is break this up into factors of perfect and not perfect. So here is the start of my cube root. And I'm going to break negative 250, looking at the cube root column, I'm going to break it down to negative 125 and 2. X to the 6th is perfect, so I'm going to leave it alone. And I'm going to break y to the 5th into y cubed and then y squared. And the negative 125, the x to the 6th, the y to the 3rd are all perfect, so they're going to come out. And then the rest of the stuff, the things that I have not underlined, will stay in there. So the 2 and the y squared. And what's in red is my final answer. All right, going to number 3. On number 3, when I want to break this down, the negative 32 is perfect. So is, and actually that's it. So I'm going to break it into, again, my factors. The negative 32 will be able to come out. I'm going to change x to the 6th into x to the 5th and an x, and the y to the 7th into a y to the 5th and a y squared. And now the things that are perfect, the negative 32, the x to the 5th, the y to the 5th will all be able to come out. And then the regular x and the y squared will stay in there. So again, what's in red is my final answer for number 3. All right, number 4, breaking this down into factors. 200 does not have a perfect square root, so I'm going to break it down into 102. A to the 6th is good, but I'm going to break b to the 7th down and b to the 6th and b to the 1st. And now the 100, the a to the 6th, the b to the 6th can all come out. So here are their square roots. And then inside the square root will still be, whoops, and I just realized I wrote 1 instead of b to the 1st. So what will still be in there is the regular b. And that is number 4, what's in red. All right, number 5, everything in number 5 is perfect, so the square root of 121 is 11, and then y to the 10th becomes y to the 5th. Number 6, same thing, everything's perfect, so I get 9 and x squared. All right, moving down to number 7. So on number 7, what I'm going to do is, even though there might be some things that are perfect, I'm going to put everything under one square root. So I have 5 x's, 1 y, and 8 z's. And now I'm going to break it down into the perfect and not perfect. So I'm going to have x to the 4th and an x, the y, and z to the 8th is already perfect. And now I'm going to take all the perfect stuff out. So when I'm done, I'll have x squared and z squared on the outside, and still in my square root will be an x and a y. So there's number 7. All right, number 8. Again, what I want to do is I'm going to go ahead and simplify. So I'm going to go ahead and simplify it. My fraction 125 over 15, I can simplify into 25 over 3. My x's will simplify into x to the 4th in the top, and my y's will simplify into y to the 6th in the top. So when I look, I technically still have a 4th root down in the bottom. So what I'm going to do is build 4 up with another 4th root. And I want to look using my exponent table, what's the first number I can turn 3 into that has a perfect 4th root, and that's 81. And I can turn that into 81 by taking 3 times 27. So now, as far as my denominator goes, I have the 4th root of 81. My numerator, I'm going to go ahead and put everything together. So I'm going to take the 25 and the 27 and multiply them. And here come the x's and the y. And now I'm going to take everything perfect out. And I realize I could have taken, for instance, this x to the 4th out from the very beginning, but I'm just taking it out now. So here's my final answer. 675, that will not be able to come out. And I know it's not going to be able to come out because I've already done all my simplifying ahead of time. Let me move this over a little bit. The x can come out and some of the y can come out, but I'm still going to have a little bit of the y left in there. And then in my denominator, everything was perfect. So I'll just take the 4th root of 81. And when I take the 4th root of 81, I'm going to get 3. So in blue, there is my final answer for number 8. All right, moving on to number 9. Again, I know there's some things that are probably maybe perfect, but I'm going to go ahead and just put everything under 1 cube root. So the 16 and the 6 multiply for 96. I'm going to have x to the 8th and y to the 7th. I'm now going to break it up into the perfect and the not perfect, and as it turns out, 96, nor do any of its factors have anything perfect. So it's just going to stay that way. I'm going to have x to the 6th, x squared, y to the 6th, and a y. And now I'll take out the perfect stuff, which is the x to the 6th and the y to the 6th. So in red, I'm going to have to squish this in there as far as my answer. I'm going to have x cubed, and I'm sorry, not x cubed, x squared coming out, y squared coming out, and then still in the cubed root is going to be the 96. I'm going to have to write this small, an x squared, and a y. And that's number 9. All right, let's move down to our final row. So it's probably in this row that we're going to see our rationalizing the denominator come up. We really haven't had too much of it. So looking at 10, the first thing I'm going to do is see if I can simplify just the 5/8 x fraction, which I can't. So I'm ready to go straight to rationalizing because my only issue is the 8 and the x. So first, I'm going to build the 8 up, and the first number I can turn 8 into that has a perfect square root is 16. So I'm going to multiply it by 2. And I just need one more x for the x's to be able to come out. My denominator is now perfect. I'll have 16x squared. My numerator I can combine into 10x. And now when I clean up or take out all the perfect stuff in the denominator, I'll have 4x, and the denominator will stay that way. And I know it's going to stay that way because I tried to do my simplifying and I wasn't able to do that. All right, let's go to number 11. The first thing I'm going to do is clean it up. So again, the 5 halves I can't really do anything with. The x's, I can end up with x squared in the top, and the y's, I can end up with a y squared in the bottom. So with that, what I'm going to notice is that my x squared and my y squared can actually come out. I'm going to wait to take it out, and I have to fix my 2 though. So I'm going to build up my 2. The first number I can turn 2 into that has a perfect square root is 4, and I can get there by multiplying by 2. So now as far as my denominator goes, it's perfect, 4y squared. My denominator is now 10x squared, and I will take everything out of the denominator, so I get 2y. My numerator, the x squared can come out as x, and I'm left with the square root of 10 in there. All right, finally, number 12. On number 12, what I'm going to do is go ahead and clean it up. There's no number to clean up with 10, so that's staying in there. My a's can clean up to a squared on the bottom. The b's can clean up to b squared on top, and to c on top as well. So now what I'm going to do is build this up. Whoops, I forgot my little cube. With another cube root, because nothing can come out right now. Nothing's perfect. So the first number I can turn 10 into that has a perfect cube root is 1,000, and I can get there by multiplying with 100. And I just need one more a. And as far as the denominator goes, I now have something perfect, 1,000, a cubed, and in my numerator, putting it all under one root or radical. I have 100a b squared c. And now what I'm going to do is take out all the perfect stuff in the denominator. So in the denominator, the cubed root of 1,000, a cubed is 10a. And in my numerator, since we already tried to do all our simplifying, there will be no simplifying now. And here is my answer for number 12. All right, next page. So on this page, when I deal with this, you guys, I am just going to work with everything as exponents. So I'm not even once going to think of anything as a radical unless it happens to be perfect. So that's about it. So let me move this a little bit over so you can see. All right, the main question I'm going to ask myself on this page is should I add, subtract, or multiply my exponents? So I'm going to start with the 13. So I'm going to distribute my exponent in, and I'm going to multiply, which gives me 3 6, and on the bottom it gives me 3 12s. I'm now going to simplify those fractions to 1/2 and to 1/4, and that's it. I mean, I know 363, that's the square root of 363. It's not perfect. I don't want to look for anything perfect. I'm not dealing with radicals. We are focusing on the rules of exponents, so you're just going to leave it like that. On 14, the first thing I'm going to do is multiply these two exponents. So I have 2x, that's the 11/6, and x to the 4/3 on the bottom. Now that's all to the 6th power. So now this 6 is going to distribute to the 2, the 11/6, and the 4/3. So I'm going to get 2 to the 6, and x to the 66 over 6, and x to the 24 over 3. And now 2 to the 6, that's worth 64. My 66 over 6 is worth 11. And my 24 over 3 is worth 8. And then I still have bases of the same that are the x's, so I can subtract those exponents and end up with this is my final answer. All right, 15, a couple different ways I could do this. What I'm going to do is deal with the negative exponents first and switch them around. Now they're positive. And since the bases are the same, I'm going to subtract the exponents, which the 3/3 is the same as the 1st power, so my final answer is just 27. All right, let's move to 16. So 16, I'm going to multiply the exponents. So when I'm done, I get 6 12s, which is 1/2, and unless 6 has a perfect square root, I'm just going to leave it. On 17, I'm going to add the exponents. So 1/3 and 4/3 is 5/3. 18, what I'm going to do is go ahead and simplify my fraction on the inside. I'm going to take a 2 out of everything. And now I'm going to distribute the 1/3. And the only thing that's perfect is the 27. So I'm going to go ahead and turn that into 3, but I will leave the 32. I don't care if it has factors that do, because then we're starting to work with radicals. And the focus of this side is to work with the rules of exponents. They just happen to be fractions. All right, 19. I'm going to distribute the exponent to the 3, the -2, and the 4. So it's going to be 3 to the 1/2. And time out here. I actually noticed that this has a 1/2, and the one on the assignment does not. So as you're looking at this, go ahead and add the 1/2, and I will make note of that in class. So it's going to be 3 to the 1/2, x to the -1, and y squared. And then I'm going to follow the rule of negative exponents that says that negative should go to the bottom. And that's it. I'm going to leave it like this. All right, 20. A couple people came up and asked me if that should they distribute. Nope, I'm just going to multiply the like terms. So the 2 and the 8 is 16. My m's, 1/2 and 2/5, I would be getting a common denominator of 10, which 1/2 would become 5/10 and 2/5 would become 4/10. So when I add those, I get m to the 9/10. And then as far as the ends go, I'm going to add 3/4 and technically 1 or 4/4, and that gives me 7/4. So that's it for 20. 21, going back to previous chapter, organize your numbers, the x's, and the y's. And the 2's and the y's will cancel out, so I'm just left with 6 x's, or x to the 6th. All right, 22. Whenever you add or subtract, things need to be alike, so it's very picky. But what I'm going to do is treat each term like a little problem. So on the first term, the 32 has a perfect fifth root. That will become 2. None of the x's can come out, so my first term turns into this. And then in my second term, the y to the 15th can come out and join the 7. And now what I'm going to do is see how many of these y cubed fifth root of x to the 4th I have. So 2 take away 5 says I have -5 of them. And I don't do anything as far as combining the variables. I just work with the coefficients. 23, same idea. I'm going to make my first term and clean it up. So I get x to the 8/10 and y to the 4/10, which just becomes x to the 4/5 and y to the 2/5. And now in my second term, I have the 3 to start with, but I'm going to have x to the 4/5 and y to the 4/10. And then that's going to become 3x to the 4/5 and y to the 2/5. So when I look at how many of these x to the 4/5, y to the 2/5 that I have 4 of them. All right, let's move on to the next part with our working with all these different functions. So first, I'm supposed to take f of x and g of x and subtract them. So g of x is x minus 2. And I'm going to subtract f of x is x cubed minus 8. I am going to go through and turn it into addition. So I'm going to add the opposite, and the opposite. And when I write my answer in standard form, I have negative x cubed first. Then I have an x. And then I have 6. When I ask myself the 3 questions of domain, do I have x in an even root, x in a denominator, or both? The answer is no, so my domain is all real numbers. Next one, I'm going to multiply. So I'm going to take f of x and g of x. And I'm just going to multiply or FOIL. So x cubed to x is x to the 4th. And then I'm going to have a negative 2x cubed. And then I'm going to have a negative 8x. And finally, a 16. And there is nothing to combine, so that is my answer in standard form. X to the 4th minus 2x cubed minus 8x plus 16. Again, that question for the domain, x in an even root, x in a denominator, or both, the answer is no, so my domain is all real numbers. All right, on the next one, I'm going to take f of x, which is x cubed minus 8, and put it into g of x. So when I put it into g of x, which is this x minus 2, it is going to completely replace that x. So here it goes. And then I'm just going to clean it up, and I can turn that into x cubed minus 10. Again, is x in a denominator, x in an even root, or both? The answer is no, so I have all real numbers. Now I'm going to divide them. So here's g of x and f of x. That denominator I can actually factor into x minus 2. And that's something that you could have on your cheat sheet that we've used before. My x minus 2's are going to cancel out, so I'm just left with this. Now, when I ask myself, do I have x at an even root, x at a denominator, or both? The answer is yes, I do. I have x at a denominator. But remember, the only thing that turns this into 0 are imaginary numbers. So the domain is still all real numbers. All right, next, with these 2 or 3 composite functions. First time, g is going into f. So the 2 will still be there, but instead of the x, I'm going to replace it with 4x squared. And then I'm going to clean it up. And that is my new function. No issues with the domain, so all real numbers. On the next one, I'm going to take h and put it into g. So still there will be the 4, but I'm going to have the x plus 5 over 2 now squared, which means I can't distribute. It means x plus 5 over 2 times x plus 5 over 2, which I'm going to FOIL my numerators and multiply my denominators. So here's the 4 coming along. The denominator multiplies into x squared plus 10x plus 25, and my denominator turns into 4. And then those 4's will cancel out and give me x squared plus 10x plus 25. Issues with the domain? Nope. So all real numbers. And my final one, I'm going to take h and put it into f. So the 2 will still be there. Here goes f, or h. These 2's will cancel out, so I'm just left with x plus 5. Issues with the domain? Nope. All real numbers. So, all right, final page. And there is a correction on this page. It's on the bottom one. I messed up. So I will point that out in class. On that x squared, there should not be an x squared. It should just be x. Otherwise, none of those numbers in my t-chart are going to work. And we have not graphed such a shape. All right, so the first thing it needs to do is I need to find the inverse of the following functions. All right, so I'm going to first switch x and y because f of x is technically y. And now I'm going to solve for y. So first I'm going to subtract the 8. And then I'm going to divide by 2. Or I'm sorry, negative 2. And as far as my answer goes, when I do put it in here, I'm going to write it as it would be a line. So that would be negative 1/2 x plus 4. Making the t-chart, when I make my t-chart for the original function and I put negative 2 in, so again, that's for the negative 2x plus 8, I get 12, 8, and 4. So if you just graph those points, you're going to be here, 0, 8, and 2, 4. And then technically, their inverse points should be switched. So when I graph the inverse, I should be able to graph these points. So here is 12, negative 2, 8, 0, and 4, 2. And when I do graph these lines, which will not do, I won't do well on this, you guys, because it's hard to draw a straight line on here. The idea is these should reflect over the line y equals x. And that's pretty good. And they do. I mean, again, if you have a straight edge, it's going to look a lot better than what mine look like. All right, next one, find the inverse. Again, we made a correction, so sorry about that. I'm going to replace g of x with y. And here I go to replace it. So first I'm going to get, rid of the 4th root by taking it to the 4th power. That's a y. Now I'm going to subtract 7. And now I'm going to act like there's a negative 1 and divide a negative 1 through. And so this is my new equation. Negative 1 x to the 4th plus 7. A t-chart with the original points results with negative 9 giving me 2, 6 gives me 1, and 7 gives me 0. And it goes something like this. So when I graph the inverse points, 2, negative 9, 1, 6, and 0, 7. Let's see. Whoops, that's off one. Hold on. So 2, negative 9. I'll go ahead and do 0, 7. And then 1, 6. It's going to be kind of like a halfway upside down U, going like such. All right, and that is it as far as the first one goes. Oh, and real quick, you can see that line of reflection across y equals x. Again, It'd be better with a straight edge, but I think you will get the idea. So there were 2 corrections, and I will point out those corrections to you guys. Um, check out the rest of the review on Blackboard 9. I will get that up by tomorrow, but at least you have the video part for now. Okay, that's it.